5. Make sure you know where your square root button is on your calculator. It should look, it probably looks like this. If you don't know where it is, raise your hand and I'll come help you find it.
Let's see, it's purple.
Any questions about the Pythagorean theorem? None? Let's find out. You can do these, Cheryl, or not?
I don't need to
Can you do the story problems? Down at the bottom of this, there's some that are numbered 1, 2, and 3. I want to do 1 and 2 as a group. All right, so I'm going to give you just a couple minutes here to look at this. You might want to draw yourself a picture and see if you can analyze where we're going, and then we'll work together as a group. So we're dealing with this pole guy wire problem. A guy wire is a wire used to stabilize some pole. See a lot of this in our country, where we have wind. What's that?
do these?
No, not the top ones, just down at the bottom. You see I've got ones labeled 1, 2, and 3. I'm sorry, I should have quantified that.
So
we're just doing 1 and 2 right now.
Yep. Okay, you might have had time to look at it now. I want to go ahead and work it up here. All right, whenever I'm doing a problem like this, regardless of how simple or complex I think it is, I always start with a diagram and analyzing what the information is. Okay. So, in essence, on this guy, I'm going to call this my given section where I'm writing my information. I think I can make some assumptions that the ground is flat on here. I am going to have some pole that sits like such, and I'm going to have a wire that goes, and I'm going to assume from the top to some point. I know the pole is 15 feet high. I know the distance from the pole to this point is 10 feet. So that's my given information. The next thing I'm going to do is I'm going to take a moment to analyze this and say, what am I looking for? Okay, because I can do a lot of math on this that doesn't do anything to solve the problem. Okay, I want to know where I'm going. Same analogy I use with your outlines in drafting or driving. I know you got a little phone that you type in an address and it says go up here and do this or that. Well, if you type in the wrong zip code, maybe it takes you to Idaho Falls instead of Boise. Good luck driving that distance. Because you got to go through Idaho Falls, Washington, D.C., across the Atlantic, and all the way back around the planet.
It was worth a shot.
First start right there, doesn't mean I
All right, so what am I looking for here? I'm looking for the guy wire, and here is my wire, right here. So I'm looking for my hypotenuse, correct? Next thing I do, once I've done this, I generally redraw my sketch and I get rid of all the nonsense. Okay? So in essence, what I've really got here is 15 feet, 10 feet, and side C. This will be side B. Let's go B and A there. Doesn't really matter. Let's throw this in an equation. My equation here is going to be, I usually label this solution. So I'm going to use C squared is equal to A squared plus B squared. So plug in your numbers. A is 15 plus 10 squared. Reduce those numbers. Not sure what that one is.
225.
You should have C squared is equal to 2 1/4 and 100. C squared is equal to 325. Adding those two together. Get rid of your squared. I've got C is equal to the square root of 325. Somebody give me the number when they got it.
18.027.
18.03. As the purposes of this
That's what I wrote.
class, you can round to two numbers at any time, and you will be close enough for the work we do in here. If your calculator carries it to 5 and you want to keep that going, that's fine with me. I will grade it to 2. 18.03, is that correct? Got somebody else to confirm that number?
Yes.
Don't forget, it's also feet for our answer. Don't forget your units. Any questions on how we got to them? So now we go by 20-foot chunk of wire, and we should be good. We can make that connection. Let's look at the second problem. And this one's also a hypotenuse problem. Tell you what, let me make up a problem. Because we need to see how to solve for a leg. We've been solving for nothing but hypotenuses so far. Okay, so let's just throw a triangle out here. Let's say it's got to be a right triangle. And I know this side is 18 units, and this side over here is, let's call it 8. What I want you to do here is solve for a side. Okay. Now I'm going to call this side B, this side C, and this side A. So solve for side A. Let's just make sure we can do the math. Okay, so my equation, C squared is equal to A squared plus B squared. We plug in our numbers. I've got 18 squared is equal to A squared plus 8 squared. Now, at this point, we can move stuff around here, or we can get numbers, whatever we wish to do. Let's go ahead and reduce these to numbers right now. I can do the 8 squared. That's 64. Can't do 18 squared.
It's 324.
324. Now, when I've got an equation like this, everything is an individual term. Therefore, I'm using plus minus to move stuff around. I need to move the 64 over to this side. So what I'm going to do is I'm going to subtract 64 from this side of the equation. I'm also going to subtract 64 from this side. Let me rewrite that as 324 minus 64 is equal to a squared, because 64 minus 64 is equal to 0, correct? So then we can now work this number,
260. 260.
260.
Yes.
260 is equal to a squared. And then we want to take the square root of that.
16.12.
Say that.
16.12.
16.12 is equal to side A. Can I get somebody to confirm that?
Yes.
Okay. Do you see how to do the math on that? We should have jumped right to problem 3 on there, but I wanted you to do that one on your own. We don't have enough time to go into unit conversion, and we're about done. Let's just look at this one real quick. Softball diamond, 65 feet on the square. Okay, so when we call it a diamond, what we're really dealing with there is a square that's turned on the side. Where I'm 65 feet, definition of a square. All angles are equal, all sides are equal. They're all 90-degree corners. They want to know, if you don't know, this is first base. This is home plate. This is second. This is third. They want to know the distance from here to here. Here's another 65 feet. Rewrite the triangle to get rid of the stuff. So 65, 65. We're looking for the hypotenuse. By the way, let me just throw out something. What's this angle right here, and what's that angle right there?
45.
How do you know that? No, that doesn't really work. That's not true. Not using 180 minus 90 means you have 90. But why couldn't this be 60 and 30?
It's the rule that says equal sides have equal angle.
Whenever you have a right triangle and your sides are equal, these will both be 45. You can use that to help you find answers. Because if I've got this side at 60 and this side at 70, expect that angle to be a little above 45, that one to be a little bit less than 45. And so common sense comes into play when you're punching that calculator and you get an angle of 96, and it shouldn't be there. And you go, oh, my fat fingers hit another button, and I never got it right. Just as an aside, to know what to look for. So we can label these A, B, C. And I know that C squared is going to be equal to 65 squared plus 65 squared. We won't go any further with this. Go ahead and crunch your own numbers for it. I'll wait just a moment. Juan, when you get a result, can you tell me what you get, please?
65 squared.
Of all of it. What C is. Oh, some calculators build them as equations, some.
Yes, and I have to go back and hit that first. And then-
Sounds good.
$8,450.
That's what you got right here? Did you take the square root of it yet? You're, I think, giving me that right there.
That was a long walk.
91,
91 point what?
92.
Can I get somebody to confirm that number?
Yep.
Declan, Andy, Majid. All right, that, don't forget your units. Okay, that's feet, not 91.92. It's 91.92.
Do you want 92?
What's that?
Would you want to round to 92? That was a test question.
I'd want it to 2 decimal places. No, I would not round it to 92. I don't know what this number was right back here.
It was a 4.
Round it to this decimal place.
It was a 4 was the next one.
Okay, so 4 rounded to 2. The last problem on here is kind of a fun one. I don't want to take time to do this. I think we're done for today. But if you want to do this problem, next week we'll give you the answer to it. During the summer heat, a 2-mile bridge expands 2 feet in length. Do you think do you think that's unrealistic? Not even. Not a metal bridge. Concrete bridge probably wouldn't expand 2 feet. Metal bridge might expand much more. Prime bridge is what? Metal. It's not quite a mile long. It's more like a half mile. It's not even a quarter. Can't remember.
It's not-
I
it
got the
feels
drawings for it
like
over
it's
there.
3 miles.
What's that?
It feels like it's 3 miles.
Yes,
I hate
especially
it.
when the wind's blowing, right?
Oh my gosh.
Okay. You're going to be kind of amazed at this. So you've got 2 right triangles. You might want to convert it to feet. Okay, if you need to know, 1 mile is equal to
5,280.
280. I'll write 2 something. Is equal to 5280 feet. Okay. That might help you if you switch it to feet. Because they do give you some feet. All right, please analyze that problem. I think it's a good one to do. It's kind of a story problem, so don't get distracted. Focus in on what you're really looking for and how to put it into a right triangle and solve for the solution. We will give you the answer next week. Okay, we're going to spend next week doing unit conversions. I've got a handout for you on this one. It's not in your text, so you're not going to pre-read anything. In essence, we're going to take a bunch of numbers and times them by 1. That's unit conversion. But it takes a lot of different forms. It can be fairly confusing. Okay, so we're going to spend a little bit of time on that. I found that this is a math that threw many people on the job site. And I don't mean just drafters. I mean engineers, architects, nurses, construction people. You all have to convert. And many people don't do a very good job of it. So we're going to spend a little bit of time on this. That's it. That's all I've got for today. Any questions on what we covered? Yes, Declan?